Okay, for question 1, you may be wondering why certain keyword is required. That is because in the question, they mention these two keyword, evenly spaced and parallel. So because of these two keyword in your response, you need to indicate what does these two key condition implies. So when you see that they specifically mention that the lines are parallel and evenly spaced, you need to be able to point out that the magnetic field is actually more uniform. Whereas in A part 2, okay, all they mention is that the lines are far apart. So when the lines are far apart, what does it imply in terms of the property of the field? Well, it become weaker. Okay, and since they provided 2 point x and y, it is best that you include some comparative words. So that's for your question 8, which is like an appetizer. Then for question 11, right, I'm actually quite surprised that many of you have encountered difficulty here. The first thing is that you need to take note that the light emitting diode is actually one form of diode. It is different from light what you call that, light dependent resistor, your LDR. So LDR and your LED, they are different thing, right? Your LED is a type of diode, whereas your LDR is a type of resistance. So for the first question, although they give you a very weird looking graph, do not panic. Whenever you encounter a new graph, always ask yourself what is the y-axis and what is the x-axis, and then ask yourself what does it imply in terms of the gradient, because for every graph the gradient will tell you the most information. So for this particular example, when I see that they give us a current versus voltage graph, I immediately ask myself, what is the gradient? What does the gradient imply? So in this case, if you look at the gradient, which is the difference in the y-axis over the difference in the x-axis, basically the gradient of this particular graph will give you the reciprocal of resistance. And what does this mean? Basically, it means to you that when the gradient is gentle, it indicates that the resistance is very high. So for example, this segment where the gradient is very gentle, in fact the gradient is 0, it means that your resistance is almost infinite, right? And when the gradient is very steep, for example this part of the graph, it means that the resistance is very small. So whenever you are given a graph and you know that eventually the question is going to require you to interpret the graph, always check what is the y-axis, what is the x-axis, and then what does this gradient implies. And then after that, try to form a certain trend in your mind. And by the time you take the O-level exam, you should be so comfortable with looking at gradients and the trend that you can immediately form this kind of co-relationship in your mind. It's okay if you cannot do it immediately, but you need to write it down if you know that this is one of your weakness. Okay, some of you have very little RAM in your brain, meaning that you cannot retain short-term information. So if you can't do that, then just write it down lah. Okay, then it will help you in your logical deduction. Then secondly, when the question asks you to describe a certain trend, you need to be very mindful what is the subject that they are interested in. So for example, if you look at this particular attempt on the question is looking out for the change in the resistance with the change in resistance relative to the potential difference, which is actually the x-axis. But if you look at this student's attempt, right, it says what? When the potential difference increases from 0, okay, fine, there is drastic increase in the current. Up to this point, right, is the student getting any credits from this question? The answer is no, because the question didn't ask you to explain. It is asking you to describe, right? And what they are looking out for, this particular description, is the change in resistance. But this student is talking about what? Drastic increase in current, which means that up to this point, there is no credit, right? Even if you are right, then so what? You can't score anything. Then after that, he continue. The gradient has a very huge gradient. Which part of the graph are you referring to? If you look at what the question referred to, they want you to look at the LED. So if you look at the LED, there are two parts of the graph. This yellow part followed by this green color part. So which is the part with the huge gradient? He didn't specify, right? You see? He only say that, oh, generally when the potential difference increase from 0, then the graph will have a huge gradient. What do you mean by the graph? Which part of the graph, right? So when you are asked to describe something, you need to be able to actually break a very complex graph into parts that you can describe easily with one or two key adjectives, right? Then finally, he said, this means that the resistance of the LED is almost 0. Well, finally, only at the last sentence, from here to here, he finally referred to the subject of the question. By then, he have wasted his time writing from here to here. Is pure waste. And in fact, down here, I didn't even want to give him 1 mark because he didn't specify which part of the gradient, right? If during benchmarking, the teacher decided to be kind, maybe I will give him 1 mark, but that is all, right? Worse, maybe the conclusion is that, oh, this is worth half a mark, but then the smallest increment of mark we are giving is 1, so 0 lor. Yeah, it's round down. Okay, so if you are encountering this kind of question that they are asking you, can you describe a particular part, describe a change on a graph? What you need to do is first, you look at your graph. So in this case, we are looking out for LED, right? So from the LED, try to break the graph into parts, into segments that you can then manage in your description. So here you can see I want to break it from 0 to maybe about 2.6 volt. Then from 2.6 volt to around here, it will be the other part. So I will break the graph into yellow part and green part, right? Then the question asks me what is the resistance, right? And I know that the resistance is having an inverse relationship with the gradient, right? So from here, I can see that, oh, down here, my gradient is almost 0. This means that the resistance must be almost infinite. It's going to be very high. Then when I look at the green part, oh, okay, it is very steep, right? So I know that the gradient here will be increasing all the way up to infinity. So what does this mean in terms of the resistance? Well, it means that the resistance will drop all the way to almost 0 because it's a inverse relationship, right? Then I just need to verbalize this model that I have constructed in my mind. How to verbalize? Break it into 2 parts lah, right? From 0 to 2.6 volt, what happened? The resistance is very high, right? If you are very confident and you know what you are doing, you recognize that this is a diode. When the resistance is very high, what does it mean? Or it is acting like an open circuit. Then after that, break the other, go and comment on the other segment of the graph. Or beyond 2.6, what happened? Or I will talk about the trend. Or the resistance drops, and I feel that it is not just a drop. It actually dropped from infinite to almost 0 within a gap of 1, 2, 3, 4 tiny squares. So I feel that it actually dropped very rapidly to almost 0 because I know I'm talking about a diode, and that is a property of diode, right? The property of diode is that for a certain activation voltage, it will behave very differently, either as an open circuit or as a zero resistance wire. So it really depends on your content mastery. But from your answer, the marker actually can tell how much you have mastered that part of the content. Yeah. Okay, then finally, you are asked to actually continue sketching the graph, okay, for the negative part of the value. So you need to, they are actually testing you on your knowledge on the property of this component. So from here, you know that if this is a diode, it means what? It means that if down here it is behaving like an open circuit, if it fall below the activation voltage, what is the activation voltage? You notice that at this particular point at 2.6 volt, the diode behave very differently, right? On the left side of 2.6 volt, it behave like open circuit. On the right side, it behave like a typical wire. So what does it mean? It means that it is going to continue to behave like an open circuit below 2.6. So you are going to have your LED line over here. Some of you are worried, hey, if I draw my line on the axis, can the 60-year-old professor back in Cambridge see my line or not? I can tell you, yes. Okay? So stop telling me that, oh, I'm worried, so I will draw a floating line. I don't want to see any more floating line. We can see one, trust us. Okay? Yeah? So please stop drawing your line as floating line. And if it is supposed to be on the axis, what you can do, if you are afraid, just draw beyond the axis lah. You draw until like this, right? I can see that there's a tail here, right? I will be able to know. Okay, so when you want to draw the negative part of the LED, that is how the LED graph should look. Then after that, they are asking you, what will the filament lamp look like? The graph of the filament lamp look like? Oh, wow, teacher, you never teach this in class It's not even in textbook. How to answer? Okay, this is what we mean by adaptive thinking. Okay, you ask yourself, light bulb, filament light bulb, where did I use it before? In the lab. How does the filament light bulb look like? Oh, it's like this. Got one light bulb, then after that got some plastic casing, then got two pin. This is where you will put your crocodile clip, right? Then you go and put your thing, right? Ask yourself, right? For your crocodile clip, if you clip, if the light bulb has positive junction and a negative junction, does it matter whether you link it with the battery like this? Or if the battery is like this, does it make a difference or not? Will one orientation of the battery cause your light bulb to off and then the other one you can on? Yes or no? No, right? So that's why when you are encountering with questions that you are like, I really have no idea leh. Okay, I search my brain out, content never teach. Then you need to tap on your general knowledge or your experience in the lab, right? So for filament lamp, does it matter whether you're connecting the left side as positive or the left side as negative? No, it doesn't. So what does this mean? This means that actually if the current go clockwise or the current go anti-clockwise, the light bulb is going to behave the same way, right? So what does it mean? If behave the same way means what? Right? It means what? It means that if let's say you are at positive 2, PD positive 2, then now I want to draw PD for negative 2. So PD for 2, you are going to get this. Correct or not? Then if it's negative 2, well, I will get here, or will it be how many square? 20 half. Or will it be at the bottom? Here or here? Well, you ask yourself lah. If let's say I have a circuit like that, right? Then after that I put a galvanometer. Now you know what is galvanometer already, right? It will tell you the direction of the current, right? So let's say I put in a galvanometer, right? So my galvanometer is here. Then I got pointer here, right? Correct or not? So now I go and connect. Oh, okay, connect already. Oh, connect already. Then how will the current move? Oh, the current will flow from here, then go through here. Then how will my pointer react? Well, my pointer will point here. Correct or not? Maybe to the positive side. Okay, then now I change my battery. I change it to like this. So when I change my battery until like this already, right? Then the current will go here, right? Then like that, go here. Then this one come out. Then how will the galvanometer point? It will point to the negative side, correct or not? So what does this mean? This means that when my voltage is negative 2, right, my current will become negative also lor. So what does this mean? If I keep on doing this, positive 4, it is 40. So negative 4 minus 40 lor. So what does this mean? This means that if my line in the positive zone looks like this, my line in the negative zone will look the same. Correct or not? Yeah lor, like that lor. So that is how you solve for this. Am I trying to belittle you? No, I want to say that this is a tough question, right? But don't forget, what is this objective of subject day? I want to stretch you from a B3 to a A2 to a A1. I want you to answer this kind of question because I already know you can answer all the basic question. What you need is a bit of boost to change your mind frame so that you can learn my mind frame on how I handle question that you will feel insecure, and then you see that, hey, I never do this before, then how to do? Because I know that for your group of students, you have done your revision well, you have done your homework, you have been exposed to the standard question. So I want you to understand, if I encounter this question that I've not seen before, it is a stretching question. It is meant to differentiate the A2 and the A1. So how do I go about solving it? Okay, so in this video, you will find that I use a very pushy tone to actually push you to answer this kind of question. Yeah, how do you settle a question that you have not seen before? I'm verbalizing my thinking so that you can adopt, right? So what are the steps that I take here? Well, number one is you need to know what is a diode lah. If you don't know what is a diode, then you will not be able to get the diode part correct, right? But can you get the part on filament lamp correct? Can, if you practice a bit of reverse psychology, right? You ask yourself, oh, okay, let's say I ask myself in the experiment, this is how I feel. A light bulb, doesn't matter my battery left or right, correct or not? Positive or negative, right? Both will work. Okay, if I have a negative voltage, will I get a negative current? Yes, of course you will get a negative current, what? Right? Because when your voltage change polarity, the direction of the current will also flip, correct or not? So that's why if you go and put negative 2 voltage, you are going to get a negative current. Can at least you learn something, right? Okay, carrying on for your part B. For your part B, you are supposed to sketch a circuit, and for unknown reason, I'm actually quite puzzled. Why is it that when you draw the DC power supply, you guys will draw it like this? Okay, you can just draw the normal DC power supply as a battery, is fine. Okay, then most of you are able to actually get the lamp correct. Okay, this part I'm also a bit puzzled. Obviously, these students are aware that this is a type of diode. Why is it that you will add this thing? Is it because they mention light? Okay, don't worry, if it is a diode, just draw a diode. Okay, you don't need the light part. Then after that, he also got the current over here. So with this, you can see that this basically is a very simple series circuit. Okay, and by the way, you need to take note that if you put your orientation like that, your current is going to go this way. So please make sure that the direction of your diode is correct. If not, you won't be able to even form a closed circuit. Yeah. Okay, for the last part, it is pretty straightforward. Okay, especially those who have attempted it. They are saying that the current going through the circuit is 40 milliampere, meaning that down here you are going to have 40 milliampere, and because it is a series circuit, you are going to have 40 milliampere throughout, right? So you are actually being asked what is the voltage of the power supply. So you need to refer to your graph. At 40 milliampere, which is this line, you are going to get actually both the lamp and the light emitting diode to actually give you the same voltage, which is about 3.6 volt. So down here, if you are getting 40 milliampere according to the graph, you are going to get, sorry, how much? 40 milliampere, you are going to get 3.4 volt. Okay, so here you are going to get 3.4 volt across your light bulb, and you are also going to get 3.4 volt across your LED. So because it is a series connection, if you are using 3.4 volt here and 3.4 volt here, the EMF, you need to add them together. Okay, so here, because you are actually being asked to read from a graph, okay, they will give you some leeway in terms of your reading. So if you believe that this is 3.4 volt, is accepted, or if you believe that it is a 3.5 volt, it is accepted. But down here, your EMF, you need to show that you are aware that this is a series connection and that you should take the PD and add them up together. So it's either 3.5 times 2 or 3.4 times 2 volt, up to you. Okay, then after that, you are being asked to find the total resistance of the lamp. So I think this one you can see that it's just out of the LED plus out of the lamp, and then you will get the answer. Right, how do you find this? One of the R is actually pretty straightforward. It's just I over V, and your I is 40 milliampere. So like I said, if you are in this group, you shouldn't be making this mistake, and I'm quite glad that none of you actually make this mistake. So you can either divide by 3.4, right? Or if you want, you can also divide it by 3.5, but please make sure that you have included the total resistance. Yeah. Okay, last but not least, you are actually asked, this is a stretching question. So again, if you got it wrong, don't worry. I expect you to get it wrong. The reason you are in this group is because you can get all the basic one correct, but this kind of question you may have difficulty. So a lot of you all are not aware of the difference between filament lamp and LED, and the implication of it being used in an optical fiber cable. Many of you are telling me two types of answer. Some of you rightly point out that the efficiency of your LED is actually very high. Some of you are telling me that the LED produce brighter light. Yeah, actually none of these are correct, because they are very specific. They wanted its application in terms of fiber optic cable. So they are checking your general knowledge. So what is fiber optical cable? If you think about it, what is its use? Its use is on communication, correct or not? And what is the medium of this communication? Is by either sending a light signal, correct or not? So if you are telling me that using LED give you brighter light, does it matter to a communication which relies on light signal? What is light signal? Light signal means I want to say yes, I will turn on the light. I want to say no, I will off the light. Does it matter if it is a brighter light? No, there's no stronger yes, right? There's only yes or no, ones and zero. That's how computer communicate. So they are checking whether you have this general knowledge of how a fiber optic cable works. It is a communication device that communicate 2 bits of information, either a yes, a 1, or no, a 0, right? So a brighter light doesn't matter. Energy efficiency, well, you can argue that we can barely accept it if our benchmarking is kind enough. So what is the most important method to communication? Is speed. So if you tell me the most important criteria about communication through light signal is speed, then my question to you is, filament lamp produce light, right? How fast is this light traveling? 3 times 10 to the power of 8 meter per second. LED produce light. How fast does this light travel? 3 times 10 to the power of 8 meter per second. So actually the speed of light produced by lamp and the speed of light produced by LED is both the same, right? Are both the same, right? So speed becomes not our answer. So what could be an answer? Mechanism wise, can you think of some difference between filament lamp, how it produce light, and LED, how it produce light? Okay, then you may ask, teacher, we never learn how LED produce light. Have you learned how filament lamp produce light? You have, right? How filament lamp produce light? Well, a current will flow through a very thin filament wire. That wire will become hot. Then at a certain temperature, the temperature will be so high that the filament wire will start to glow, and that is how you get your light, right? So how many steps does it involve? Many steps, right? So when you turn on and you turn off a filament lamp, the response time is actually slower than your LED. Okay, so actually the answer for this is that for your LED, the response time is actually much faster than your filament lamp. Okay, so this is a stretching question. Why? Because it really check whether you have this general knowledge on number one, do you know how a fiber optic cable work? Do you know what does it do? And number two, do you know the difference in terms of how light is being generated in a filament lamp versus a LED? So LED, you do not know how does it generate light, right? It's not in your scope. But filament lamp, you know, it takes certain time to heat it up, and then when the heating reaches a certain temperature, then light will be emitted. So definitely this way of producing light will take a longer time compared to LED, right? So because of that, the perfect answer actually is about response time. Okay, but instead many of you are telling me efficiency, but I can foresee that for Cambridge, I'm pretty sure that our cohort, many of them do not know how to answer this. I think most likely they will accept the part on efficiency because that is an advantage, but not the main advantage.